All right, this is going to be our unit 0, lesson 4 for pre-calculus. Unlike the last lesson, we're going to take this one in one big mouthful. We're not going to split this into 4 videos. Now, I will address the elephant or the headphones in the room. I'm wearing this because it's technically during office hours right now, and so I need to be able to hear if I get a Discord notification of somebody jumping into office hours, so I can pause the video and go help them out. So you may or may not have been curious why I was wearing headphones. You may have thought, does he always wear headphones? No, I don't usually, but I am in this video. So there you go. In case you're curious, question asked and answered. So we're going to jump in with some examples. I guess I should probably switch over to where you can see what I'm writing, and that would probably be helpful, wouldn't it? So to find nth roots, that's kind of the first part of this topic. So we're talking about things like cube roots, or things like fifth roots, or whatever else. Square roots would also be nth roots, but typically we just say nth root. Now, the 3, of course, has its special name, just like square roots. It's called a cube root, right? And so, some of them have other names and things like that. But that's what we're talking about. Now, the answer that I'm going to give for how to solve these nth root problems might feel a little like a cop-out. But right now, we're in a modern math class with modern tools. And if you're in pre-cal, you already understand some basics, and you ought to probably understand how to simplify some roots and whatever else. So if you're given an example like the negative, this one's just a straight up square root, so this one's even easier. This one you make it do in your head. Square root of 49, and you don't for some reason know that, stick it in your calculator. Move on with your life. It really is fine. The thing that you need to know, which you probably could figure out with this in this review space, is this negative is just going to hang on till the end. So the answer to this guy is -7, right? So let's do another fairly straightforward example. This is going to be example number 2. To find the cube root of 64 over 27. So now the cube root, in case by some minor miracle you don't know what a cube root is at this point, a cube root is, square root is what times itself equals that number. Cube root is what times itself 3 times equals that number. So what times itself 3 times, excuse me, equals 64. Just like what we did where we split square root top and bottom, we do the same thing here. So the cube root of 64 is 4, because 4 times 4 times 4, yeah, that was the right number of times, is 64. And the cube root of 27 is 3. So this answer to this problem is 4/3. Let's do one more. How about number one more of this kind, and then we'll do something that is not you can't just plug it into the calculator. I know you're getting all excited, like, oh, this is going to be the easiest lesson ever, and it is, but it's not just calculator work. Okay, so what about the 4th root of -121? Now, you probably are already having some bells ringing in your head and whatever else on this particular problem, because you can't do that and get a real number. You cannot get a real solution. Now, you could probably find a imaginary solution to this, but you can't find a real solution to this. And so the answer is no real solution. And in case you're like, well, wait a minute, why? Then I will explain it to you. Give me half a second. You can't multiply a negative times a negative times a negative times a negative, any even number of negatives, and get a negative answer. Because these guys would turn into a positive, and these guys would turn into a positive, and then you end up with a positive times a positive, which of course is a positive. So you can't multiply an even number of numbers and get a negative answer. So there's no real solution to that problem. So if that's all it is, then this is super duper easy. But let's throw some letters in there, right? So this is example 4. What if our instructions are simplify and the problem looks something like this? The 6th root of n to the 18. Now, there's different ways to look at solving this problem. In my humble opinion, the easiest way, now you can do this, you can split it up into different bits, and that's not a bad idea. Like in our textbook, I'll show you on this one. On some of the other ones, I'll just go to what I think is easier to wrap your brain around. You could split this into, because 3 times 6 is 18, you could turn this into n to the 3 to the 6th, and then we've got that 6th root. I still hate the word 6th. It's a terrible word. You cannot say the word 6th without spitting a little bit. It's terrible. Horrible word. But the punchline here on this guy is that 6, that to the power of 6 and the 6th root cancel, leaving us with n cubed. And that's, on this particular problem, you're thinking, well, that's pretty easy. And it is. And if this way always makes more sense to you than what I'm about to show you / remind you of, then you can find this factor in there, go for it. And that's great. You can also solve this problem by converting it from radical form to rational form, which we're going to talk about here in a minute. That's the real exponents part of this video. So if you remember, we can convert between a to the x and the yth root. We can turn this into a to the x over y, right? So this root goes in the denominator of the exponent. So in this particular case, this would turn into n to the 18 over 6. 18 over 6 equals 3. So it's kind of getting to the same place with the same ideas. Just kind of getting there a little bit different. This, to me, makes more sense because I can see real easy 18 divided by 6. So this has always been easier to think about this way. This one feels like we're having to kind of stretch out too much stuff. But whichever method makes more sense to you is totally fine. Either way, on this particular problem, the answer is n cubed. Let's do another example. Example number 5. Oh, look at that. Sorry if there's been anything y'all couldn't see well. I apologize. Hopefully it was just the problem number, if anything. All right. Let's see that was smushed over off of that screen there. Excuse me. So let's do another one that's a little bit more complicated looking. Let's do the 4th root of 81 times a plus 1 to the 12th. Now, we got a lot of puzzle pieces going here. We've got a product inside of the radical. Now, you may remember, I think we've talked about reducing radicals at least a little bit in here, I think, maybe. I may be thinking about a different class. But either way, reducing radicals, you can, if we have a product inside of a square root, this could be 4th root, 5th root, etc. So like a times b, we can split this into the square root of a times the square root of b, right? And so we're going to kind of take that same tack here and split this into the 4th root of 81 times the I was going to skip a step, but I think I'm not going to here. I think we're going to walk it on out. The 4th root of a plus 1 to the 12. Now, let's do this one, both of those methods. You can do them both in either method that makes sense to you. So 4 goes into 81 how many times? Well, actually, we don't even have to do that because actually, and you can verify this if you punch it into your calculator, the fourth root of 81 has a straight up whole number answer. It's 3 because 3 times 3 times 3 times 3 is 81. So that one just turns into 3. Nice. Now this one, I'm going to do it with rational exponents. So this would turn into a plus 1 in the numerator of the fraction would be the power, so 12. In the denominator of the fraction would be the radical part, the root part, 4. 12 divided by 4 is 3. So this problem simplifies into 3 times a plus 1 cubed. Now, technically, and you'll see this in the problem. Whenever you have variables, and this would have been true on this problem. I forgot to mention this as well. That technically, if we have a variable in here, we really, to get the answer completely right, we have to add a little something because we know that in order to get a real solution, we have to have a positive in here. So we have to add absolute value of the variable part in there to completely get the right answer. Okay, so there is that. Let's look at, I was going to skip that example, but then as I was actually looking at it, we probably shouldn't. Let's do another example. This is going to be example number 6. So, the square root of 63y cubed. Y cubed. Now, we're going to split this, like we did before, into the square root of 63 times the square root of y cubed. Now, this doesn't reduce anymore. 3 is not divisible by 2, so this part is finished, but we can reduce this radical. So the square root of 63, like if you punch it in your calculator, it's going to give you some decimal, blah, 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 blah. We want an exact answer at this point, but we want to simplify it and reduce it. So how do we do that? Well, I think we've reviewed this already, but in case we haven't, we look for a perfect square. So 4, 9, 16, 25, etc. 36, 49, on to infinity, right? And we need to find one of these that goes into this number. 9 goes into 63 because 63, and so we can turn this into the square root of 9 times the square root of brain freeze. Yeah, it was 7. I was afraid that I was lying to you. I don't know why that seemed wrong for a second. You heard me say it's on camera. Cubed. All right. So the square root of 9 we can figure out. So this ends up being 3. What we need to do to finish, we don't want a square root times the square root with our final answer. So we need to shove all the square root ones back together. So this is turning into the square root of 7y cubed. And this ugly thing is as simple as that particular problem gets. There we go. Let's look at some rational exponents. We're going to do I think we can get away with just one more example. Maybe 2. We'll see. I'll see how it feels. Let's do this one and see what we're doing. So this is going to be example number 7. And we're doing great on time for this video. It's going to be good. So we're going to do example 7, and we are finding the 10th root of 32. And on the bottom, we're trying to find the 6th root of 2. Okay, so we need to simplify this. This is getting a little wacko. So we notice, what you might note now, this one, you could put it in your calculator to verify whether you get it right, but we want to keep our answer exact, so you can't completely just punch it in the calculator and get an exact answer. Well, actually, some modern calculators you can, but let's walk through this one, the pieces of the puzzle. What I was going to say before I was thinking about calculators, is that we've got two different bases. We've got two different numbers inside of here. So it'd be really helpful if we could turn this 32 into a 2. We can, because 32 is the same as 2 to the 5th. Right? So we're trying to get our bases to match, which is so that's how we would know to check 2. In case you're a little concerned about that. How would I know what number? Well, you're trying to get the bases to be the same. So hopefully this number to something will equal that number. That's kind of what you're going for, okay? So the 10th root of 2 to the 5th over the 6th root of 2. Now, we need to clean this up a little bit more, because now that we've got like bases, we can use our exponent rules. All right, so let's deal with this first. Okay, so let's see if we can clean this guy up a little, right? Because this could turn into 2 to the 10 fifths. That's easily reducible. I'm going to go ahead and, because we're going to want to do this in a minute, I'm going to go ahead and switch this guy over from radical form to rational exponent form as well. So we're going to turn this into 2 to the 1/6. That word, terrible, keeps haunting me, haunts my dreams and nightmares and everything else and all the things. So now this guy, we can turn 10 fifths into 2, because 10 divided by 5 is 2. So this will be 2 squared, which does have a result, although we're not going to turn that into 4 yet, because then our bases wouldn't match top and bottom. So we're going to leave it as 2 squared. So now if we have like bases divided, what do we do with those exponents? We subtract them, right? So this turns into 2 to the 2 minus 1/6, which turns into 1 and 5. Yeah, it does, but I'm writing it in the wrong place. 2 to the 1 and 5/6. Now, we need to turn that mixed number into an improper fraction. So that equals 2 to the 11/6. So that right there what did I do wrong? Oh, I know what it is. Did you catch it already? Sorry, my bad. That was not at all that I made a mistake. I made a mistake right there. Hopefully you caught it when we were yelling at the screen before I caught it. That should have been the 5 in the numerator and the 10 in the denominator, right? The root goes in the denominator, the power goes in the numerator, which means that this guy turns into 1/2, which means this guy is 1/2, which means this guy is the much easier to deal with 1/3. And so where we should have been is we could leave it like this if it doesn't say whether we want to leave it as rational exponents, or if we want to convert it back to radical form, we could also have the cube root of 2. Both of those are valid, simplicity, and all of those things. I think we're going to do one more example. We're pushing up on 20 minutes. I don't want to get too much longer than 20 minutes in these, but I think it would behoove us to hit this one other example, because if you've not practiced this a lot in Algebra 2 or whatever else, some extra examples and extra practice of this particular topic would probably be useful. So we're going to simplify the fourth root of x to the 21. I don't know why I wrote it all crazy like that. Times y to the 15. Okay, so let's see if we can first split this up into two pieces. So we're going to turn this into the fourth root of x to the 21 and times the fourth root of y to the 15. Now, for this guy, let's see. We were using properties of exponents in our last example. Let's see if we can do the same thing again. Because if we have like bases multiplied, x times x, x to the a times x to the p, what do we do with those? We add them. So this equals x to the a plus b, right? So we could split this up into something that is going to let us reduce by 4. So we need to turn this 20 into whatever the biggest number that is divisible by 4 is in this number. So the biggest, excuse me, 4 goes into 20, right? 4 times 5 is 20. So what we can do is we can turn this into the, let me do it over here, I think. Let's also switch it to radical form. So this would turn into x to the 20 times x to the first. We'll turn that into just x here in a minute. Actually, we won't. We'll turn it into something else. To the 1/4. That doesn't look like a 4, does it? How about that? It's a little better. Okay. Times, I'm going to turn this into rational exponents as well. Let's see, what can we get into here? So 14 doesn't work, 13 doesn't work, but 12 does, right? So we're going to pull 12 out of there and turn this into y to the 12th times y cubed to the 1/4. Now, if we have these in here, this product to a power, we can essentially distributive property this 1/4 in there, right? So this would turn into x to the 20/4 times x to the 1/4. I'll leave these parentheses on. We actually don't even need them on this line. We could drop them here, but I'm going to keep one more line just to kind of keep it all clarified and whatever else. Then this would turn into y to the 12/4. I know you could have probably jumped all the way to this is 5 and this is 3, but I'm wanting to make sure on some of these videos in this review section especially we walk it through really, really solidly. This would be y to the 3/4, right? So, excuse me. So let's see if we can walk a little bit further. So we can deal with that. So this would be x to the 5 times, I'm going to switch it to the fourth root of x. Switch it back. And then times y cubed times the fourth root of y cubed. So these fourth roots can get shoved back together. Everything that's a fourth root can go back underneath that radical. So on the outside, we've got x to the 5th, y cubed, times the fourth root of x times y cubed. There is a heavy-handed, quick-ish review of real exponents and nth roots. If you're one of my students, I'll see you in class. Don't forget to do your homework, all of those things. If you're not one of my students, thanks for joining me. Hopefully this was helpful to you. What else can we help you with math or science or homeschooling in general? Y'all have a wonderful day. Bye-bye.